Hi class, we're still working with word problems. We're on 6.8 notes, day 2, and this is the second problem, so we're using our graphing calculators to solve for these ones. So NASA's KC-135A aircraft flies in parabolic arcs to simulate the weightlessness experienced by astronauts in space. The height of the aircraft in feet, t seconds after it begins its parabolic flight, can be modeled by this equation. What is the maximum height, this is letter A now, of the aircraft during this maneuver, and when does it occur? So here's what happens, class. This aircraft, it takes off and it starts this parabolic flight, right? And then all of a sudden, right at about the top, or at the top, it shuts off its engines, okay? So it's got nothing. So all it's going to do is it's just going to fly right back down to the earth again, right? And it's going to satisfy this experience of weightlessness that they want these astronauts to experience. So instead of actually going to space to experience it, they're just going to let them have a free fall. So during this time in here, when they are just falling at the speed of gravity, they are weightless. Okay, so now they can float around and all this different kind of fun stuff. So that's what's happening. And it says, letter A, what is the maximum height of the aircraft during this maneuver? So how high does this aircraft go? What point is that? And as you've seen from the past few problems in the past couple days, that is our maximum value. So let's find that maximum value. The way that we do that using our graphing calculators is we put this into our y equals. So once again, h of t, that's going to be our y variable, and t is going to be our x variable. Okay, so we're going to put this into our graphing calculators. So we had this in here. Before I start this, let's go back to our window. It's all kind of messed up from our last problem. If you press zoom 6, it goes right back to a -10, +10, -10, +10. And that's the most standard graph that we always have. So if you ever want to turn it back to that, just press zoom 6. So now we're going to y equals, and now we're going to put in our new equation. So you can delete the one that's in there, or clear it rather, don't delete it. Clear it. And then we're going to put in a -9.09x squared. A -9.09x squared. We're going to add 590.85x. 590.85x. And then we're going to add 24,398 plus 24,398 point 6875. Whew, that's a big one. I forgot the decimal. 6875. 6875. Okay, there we have it. And now we're going to press graph. And as you can see, once again, our window is not set up correctly, and hopefully that makes sense to you. Right now, our y-axis goes up 10 feet. How high do you think this aircraft goes? It goes up quite a few feet, right? And as you can see from our problem, it says the height of the aircraft right here is in feet. So I'm thinking this aircraft, if you guys know anything about, kind of using common sense, how high do you think an aircraft goes? Well, to experience this weightlessness, I'm assuming it would have to go up a couple miles or two. A mile is 5,280 feet, so 2 miles would be a little over 10,000 feet, right? So this is kind of what you're thinking in your head right now. So as we go here, let's just put in some numbers and see if we can see our graph. So you're going to go to window. Let's put in, I don't know, maybe 5,000 feet. So for our y maximum, this is how high it goes. Let's put in 5,000 feet. And let's graph that. Well, we're not getting a whole lot, are we? Let's go back to our equation. Notice this number right here. So if my time is 0 and 0, okay? This number is a positive 24,000 feet. So I know that when it starts its parabolic flight, when time is 0, I know it's going to be this high up in the air, right? So that's pretty big, and I know it's just going to go up from there. So I know it has to be greater than 24,398 feet. I'm going to have to set my y-axis bigger than that. Let's set it at, we'll just go maybe 10,000 more than that. Let's set it at 35,000 feet. 35,000 is what we're going to put our y at. So go to the window, y maximum, 35,000. Okay, let's graph that. Okay, we're seeing something kind of crazy. It's not going far enough to the right, is it? So this time aspect, let's increase that quite a bit. Let's increase that, our x maximum, to maybe go right 100. So let's go to window, our x maximum, let's go right 100. Now let's see what we have. Okay, we're seeing a little bit more. This is good. We don't have everything to the left, so maybe let's move our x minimum, so going left, this is the minimum of our x value. Let's go maybe a negative 100 for that one. All right, we got something. That looks like it would be a parabolic flight of this aircraft. Now let's also get a little bit below the x-axis, so that would be our y minimum. Let's go our y minimum, instead of being a negative 10, oh, I don't know, let's go a negative, let's try a negative 100. Graph. Well, this is something for us to look at anyway. So if we need to change things later on in the lesson, we can do that. But for now, I would say this is a pretty standard parabolic flight that we're looking at here. And like I said, we could always change it again later. So now let's answer the question. The question says, what is the maximum height of the aircraft during this maneuver and when does it occur? So our maximum height is this point right there. And when does it occur? It occurs on this x-axis however many seconds it is. So what I need to find is I need to find that maximum point, or I need to calculate that maximum point. Second trace, which is the calculate button. What am I calculating? Once again, I'm calculating a maximum value. So go down to number 4. Calculate maximum, we press enter. It's going to ask for the left bound of that maximum. So the left bound of that maximum, maybe somewhere right in there. Press enter. Now go to the right bound of that maximum. We'll go right about, oh, right there would be good. Enter. And now it says guess, so try to put your cursor right on the top, right on the peak of that hill. And our maximum value is when our x-axis is 32.5 and our y-axis is 34,000. Just as I have right on here. Our x-axis is 32.5. Our y-axis is 34,000. So to answer our question here, our question is, what is the maximum height of the aircraft during this maneuver and when does it occur? Our maximum height equals, how high is this? That's the y-axis, 34,000 feet. 34,000 feet. And make sure you answer the whole question, when does it occur? When does it occur? So that's going to be our time parameter. That's the x value. So it occurs 32.5 seconds. And this question is maybe a little bit difficult. It's not 32.5 seconds after the plane takes off. It says that, oopsie, t seconds after it begins its parabolic flight. So this aircraft is going to start flying up into the air, not necessarily as a parabola, but then once it starts its parabolic flight, it's going to hit the maximum 32.5 seconds after that. So it occurs 32.5 seconds after it begins its parabolic flight. So once it starts going in the shape of a parabola, 32.5 seconds after that, it is where it's at its maximum point, which is right there. All right, letter B. Letter B says, if it is only safe for astronauts to have a 45-second free fall. 'Cause I'm free! I am free, free falling! I like that song, and it always, whenever I hear free fall, that's what I think of. Anyway, it has free fall, which is weightlessness, for 45 seconds, which I think would be sweet, just to chill around, right, and you're up in the air and stuff like that, and nothing is holding you back. Oh, I think it'd be awesome to have weightlessness. But it's only safe, what did it say, for 45 seconds. How high will the aircraft be when they have to turn the engines back on again? So here's what's happened. It begins its parabolic flight. Right here it's at its maximum. They turn off the jets. And here we are. We're free falling. Should I sing it again? 'Cause I'm free! I am free, free falling! However, we don't want to free fall this whole time. Otherwise, we will hit the ground and die. So eventually, we're going to want to turn our engines right back on again so that we can go up again, and then we can come down to a nice little free fall. Or not to a nice little decline where we finally reach the atmosphere safely. So eventually, maybe at around this point, we're going to want to turn our engines back on again. So where is that point at? Right here. How high is that up in the air? So we want to find a y value. So class, if this point right here is at 32.5 seconds, we established that, right? That's the x coordinate, 32.5 seconds. That's how we got this one right here. If that's at 32.5 seconds, where is this x value going to be? After a free fall of 45 seconds, 45 seconds passes on this blue flight. So where, in comparison to 0, which is right here, where is this point at? 32.5 plus 45, that would be, adding those two up, would be 77.5. 77.5. So I want to find what is the y value when x is 77.5. How high is that? So here's how you do that using your graphing calculator. If we wanted to, we can just put 77.5 in for x, so in for this value and find what the height is. However, it's easier to use our graphing calculator, and I will show you how. Remember 77.5, that's the x value. You're going to go to your calculator, and you're going to press second. First, I'm going to erase this garbage up here. Once again, we're going to calculate something. So press second trace, which is the calc button. We're not going to calculate a 0. We're not going to calculate a minimum. We're going to calculate a maximum. Or we're not going to calculate a 0, a minimum, or a maximum. We're going to calculate number 1, a value. That value being 77.5. So press enter right on number 1. What is our x value? That's what it says right here. Our x is 77.5. 77.5. And then we press enter, and immediately it spits out our y value. So here we are at 32.5 seconds. We turn off our jets, and now we're free falling, free falling, free falling, free falling. It's been 45 seconds. We got to turn our jets back on again. How high is that? There we are right there, 15,592.75. 15,592.75. And right then and there, we're going to turn our jets back on again so that we don't fall that extra 15,592 feet and fall flat on our faces on the ground. If you guys ever have an opportunity to do that sometime in your lifetime, let me know and tell me how that free fall experience is, because I would be very curious to see how that went for you.